Hey guys, it's Manpreet here. So today we're going to be solving a problem involving a strong acid and strong base. So the problem says determine the pH at each of the points in the titration of 15 milliliters of 0.1 molar hydroiodic acid with 0.5 molars lithium hydroxide. So the first thing in solving these problems is to determine whether the acid and the base are strong or weak. So we know that hydroiodic is a strong acid and lithium hydroxide is a strong base. So we write out our reaction, and for a strong acid, strong base, it'll always yield water and a salt. And now, since the good thing about a strong acid and strong base is that they fully ionize, and so does the salt, since it's a salt. So we can write this as H plus I minus plus lithium plus will yield water and lithium iodide. So these are spectator ions since they're not involved in the reaction. So our final net ionic equation will just be this one. Now, you should remember that this is always going to be the net ionic equation when it comes to a strong acid and a strong base titration. So now that we've established that, we should go back to the problem. So for A, it says find the pH when no lithium hydroxide is added. So that basically means that we go to how much acid there is initially, and initially there's 0.1 molars of hydroiodic acid. So 0.1 molars of hydroiodic acid means there's 0.1 molars of H plus ions. pH is equal to the negative log of H plus concentration. So then this will simply be pH of negative log of 0.1, which is basically equal to 1. So that'll be our pH when there is no lithium hydroxide added. So that was fairly easy. For the next one, however, it gets a little more complicated. It says when 2 milliliters of lithium hydroxide is added. So now, when it comes to these kind of problems, I like to use the millimole just because it's a little easier than converting everything, because it keeps the numbers a little more simple. So first, let's put hydroiodic. Initially we have 15 milliliters of 0.1 molar hydroiodic acid. So to figure out the millimoles, you just do 15 milliliters times 0.1 molars, which is equal to, let's do this, it is equal to 1.5 millimoles, okay? And that would be 1.5 millimoles of H plus. For our base, we have 2 milliliters of 0.5 molar lithium hydroxide. So we just multiply those. So 2 milliliters times 0.5 molars, which is equal to 1 millimole of hydroxide. So we should remember that now. Now we rewrite our net ionic equation. And we have initial, the change, and the final. And that'll just help us sort everything out. So initially we determined that for H plus there's 1.5 millimoles, and for hydroxide there's 1 millimole. Now water is a liquid, so we don't account for it when we're doing these problems. And so this is almost like a limiting reactant problem. Basically, you look at the millimoles, and whichever is the one that's less, you subtract it from both, since that's the one that's going to be used up. And now from this, there'll be an excess. This will be 0, since 1 minus 1 is 0. There will be an excess of H plus ions, and 1.5 minus 1. So we have 0.5 millimoles left. Okay, and now that we have 0.5 millimoles of the H plus, we're solving for a pH. So how do we get from there to pH? Well, basically, we know that molarity is equal to moles over liters, which is also equal to millimoles over milliliters. Now, we know what the millimoles are. It's 0.5, but milliliters is total volume. Now, for total volume, we have to remember to add the volume of both the hydroiodic acid and the lithium hydroxide. So we have 15 milliliters of hydroiodic acid, and we added 2 milliliters of the lithium hydroxide. So basically, total volume is going to equal 15 milliliters plus the 2 milliliters. So our total volume is just 17 milliliters. Now we have our milliliters, we have our millimoles. So molarity will be 0.5 millimoles divided by 17 milliliters, which is equal to 0.029 molars of H+. I really recommend that you write everything out, like how much you have of each thing, so you don't get everything confused basically. So now that we have our molarity for H+, pH is equal to the negative log of that. So pH will equal 1.54. Okay, so for the next one, for C, it says when 3 milliliters of lithium hydroxide acid is added. So we do the same thing. So we already determined that for hydroiodic, we have 1.5 millimoles. That doesn't change because we're not adding hydroiodic acid, we're adding lithium hydroxide acid. So the initial for the acid will stay the same. Okay, now we said that we're adding 3 milliliters of 0.5 molar lithium hydroxide. So that means we have 1.5 millimoles of the hydroxide ion. Now this means that the acid concentration is equal to the base concentration. And when that is true, this is basically the equivalence point. And for the equivalence point, the pH for only, now note, this is only for a strong acid, strong base titration, the pH is always 7 at the equivalence point because the solution is essentially neutral when the concentration of acid is equal to the concentration of base, because all you have left is a salt, and the salt is a neutral, so therefore the pH is just 7. So every time you have the concentration of acid equal to base, it'll just be basically the equivalence point and the pH is 7. So we got that covered. Okay, so let's do one more. And for D, it says when 4 milliliters of lithium hydroxide is added. Okay, so of course we already know that we have 1.5 millimoles of the acid, and we added 4 milliliters of the base. So now we have 2 millimoles of the hydroxide. Okay, so now let's write our net ionic equation that we determined previously. So initial, this is the change, and this is the final. So initially for the H+, we have for the acid 1.5 millimoles, and for the base we have 2 millimoles. So now, since now H+ is going to be the one that's used up, and the base is going to be in excess. So we subtract 1.5 from both, and we get 0.5 millimoles of the base left. So now this is important. This is when it's important to write down what we have. We have OH minus 0.5. We want pH. So how do we get from here to pH? Well, you have to remember that the pH plus pOH is equal to 14. So we can determine the pOH from this. It's basically convert this part into the molarity of OH minus and use that to find pOH. And then from there on we can find the pH. So we know we have 0.5 millimoles of the base, and we just need to find the total volume. Total volume for this problem will basically be the 15 milliliters that we already have of the acid plus the 4 milliliters that we added. So it's just 15 plus 4, which is 19. So molarity of the hydroxide is equal to 0.5 millimoles over 19 milliliters, which is 0.026 molars. Okay, so then the pOH, remember, is negative log of that. The negative log of 0.026 will give you 1.59. Now this is pOH, so pH is just basically 14 minus 1.59, and that'll give you 12.41. Okay, so we've basically solved all of these problems. Now, to make sure that you're on the right track and you're solving these problems correctly, if you go back to all your pH answers, you notice that the pHs are increasing. So for example, at first it was 1, then it increased to 1.54, then it went to 7, and finally it jumped to 12.41. Now, that means that you were on the right track, because remember, you were adding base to the acid, and as you increase the amount of base, the pH increase, and that's what should happen. So thank you for listening, and I hope this helps. I'll also link the ChemWiki website for more help with these kind of problems. Thank you.